We're going to be learning how to test for iron 3 ion. Iron 3 ion is one of the true transition elements. It is believed to be one of the transition elements, one of the true transition elements because it exhibits the color, because most transition elements they give out color due to the combination that exists in their D block. When they combine or give out electron in the D block, it makes them to have what color in their compound or in the solution of it because of the combination. Iron 3 is one of these true transition elements. So in this ion, what you note about it is because of its color. This is what I have here. I have the solution of it, and it happened to be very soluble. It happened to be soluble. This one is soluble and then is colored. That's one of the features of transition element. Transition element, their compound is colored, and they are likely to have colored solution like copper ion has color. Copper sulfate is blue, copper fluoride is green, and so on and so forth. So you notice that this is one of the characteristics of what true transition element because of the combination that exists in the D block. So here we're going to be analyzing for ion 3. We have three reagents. We have aqueous ammonia solution, aqueous ammonia solution. That's aqueous ammonia we have here. We have a sodium hydroxide too. We have sodium hydroxide solution, and we have a potassium hexacynoferrate 3, hexacynoferrate 2 that we're going to be using. So the basic thing we're going to be seeing here is what happened in each of these when they combine with ion 3 ion. So the first thing we're going to be doing is aqueous ammonia. And before we continue, if you are joining for the first time, we encourage you to subscribe. And if you have any question, you can leave your question in the comment section. And if I will also want to encourage you to also like and share so that some people that need this will also get in touch with this. Thank you so much. So let's go without wasting much time. Let's go ahead and do the analysis that we have here. Now I'm adding up the solution of ion 3. Then we're going to be testing with aqueous ammonia. With aqueous ammonia, I want you to note what we have here in drops. In drops, I'm going to add a few drops of it here of aqueous ammonia. We have let's add small again. Okay, what we have here is brown precipitate is forming already in drops. In drops, that is what we have. We have is forming already. You can see that. You can see the precipitate forming. You can see the precipitate forming. So we're going to be adding in excess. We're going to be adding in excess. Wow. So in excess, what we do now is to reduce the quantity. You can see the precipitate has already formed. Let's reduce the quantity so that we'll be able to notice what will happen faster. So this is the solution, the mixture. Now let's add aqueous ammonia in excess. In essence, the precipitate is still formed there too. There's also brownish precipitate there is forming. You can see this is one of the confirmatory tests for what ion 2. The precipitate is forming. So it forms brownish precipitate or reddish brown precipitate with what aqueous ammonia. in drops and in excess. The precipitate is insoluble. As you can see here, is insoluble. The precipitate is insoluble. It's actually settling down there. Brownish precipitate. Now, the next one we're going to be doing is sodium hydroxide solution. With sodium hydroxide solution, we're going to find out what we're going to get. With sodium hydroxide solution, we add small quantity of sodium hydroxide in drop. See the brownish precipitate that is formed in drops. The brownish precipitate is formed already. Let's see what we have in excess. Let's see what we have in excess. The precipitate is forming. You can see the precipitate is insoluble. It's trying to settle. It's insoluble in excess sodium hydroxide solution. That's another method. Notice that they form a brownish precipitate, already brown precipitate with what? Aqueous ammonia and then sodium hydroxide solution. These precipitates are what? Insoluble. The two precipitates we form in both of them were insoluble. Those precipitates are insoluble. That's one of the ways. These are ways of finding what? Identifying the ion, which is ion 3. Ion 3 ion. So let's deal with potassium hexacynoferrate 2. With potassium hexacynoferrate 2, let's see what we are likely to have. With potassium hexacynoferrate 2, few drop of it. We have our solution. That's for the sodium hydroxide solution. Okay. Yes, sodium hydroxide solution and aqueous ammonia. All right, let's continue. We add potassium hexacynoferrate 2 into it. You can see deep blue coloration. This confirms the presence of ion 3 ion. Note it very well. Now you know that in each of the exams, they might just have to divert from solubility, or maybe they start from solubility test, and then precipitation, separating each of the ions. Then they arrive at what? This either of this, any of these things can be used to identify the what? The ion. So you can see now with potassium hexacynoferrate 2, we have deep blue solution. Now don't make mistake of what happened with copper sulfate. When you add aqueous ammonium in excess, it gives you deep blue coloration. Remember, it does not mean that it's what? Ion 2, ion 3 solution, because ion 3 aqueous ammonia forms deep blue precipitate with what? Copper ions. Deep blue solution with copper ion, not precipitate. But then in drops, it gives you insoluble pale blue precipitate, which is soluble to give you deep blue solution. Rather, this one gives you deep blue coloration. You can see that here. That confirms the word ion 3. These are the three methods of identifying it. So in each of the exam you're going in for, always remember that once you add aqueous ammonia in a solution that contains ion 3 solution, it will give you brownish or reddish brown precipitate, insoluble in excess. In drop is insoluble and also insoluble in excess. And then with sodium hydroxide, the same thing will also happen, just like what we have here. The precipitate there, you can see the reddish brown has formed very, very well. And then this other one we have here. So thank you so much for being part of this class, and remember to subscribe and also leave your comments. Remember to share all together. Thank you so much.